All right, let's talk about something we all have, but maybe don't think about nearly enough. That incredible living framework inside you right now, your skeleton. But how much do you really know about it? Let's dive in.
So, when I say the word skeleton, what's the first image that pops into your head? For a lot of us, it's probably that dry, kind of brittle, maybe even a little spooky prop hanging in the back of a science classroom, right? But is that really what's going on inside of us?
Well, the reality is so much more amazing. I want you to completely forget that idea of a static, lifeless scaffold. Instead, think of your skeleton as a living, dynamic, constantly changing organ system. Yeah, an organ system. It is literally remodeling itself, growing, and adapting every single day of your life.
Okay, so if it's not just a coat rack for our bodies, what else is it doing? This right here is where things get really cool. It turns out your bones have a job description that's way longer than you might think.
Okay, so look at this list. Support? Yeah, that makes sense. Protection for our brain and heart? Of course. Movement? A given. But it's these last two that are the real game changers. Storage. Your bones are like a safety deposit box for critical minerals, especially calcium. And then there's hematopoiesis, which is a fancy word for something incredible. Deep inside your bones, you have a factory that is constantly churning out new blood cells. It's amazing.
So you might be wondering, how does this incredible structure even get built in the first place? I mean, it doesn't just show up one day fully formed, right? No way. It's a lot like a massive construction project that starts with a very simple, very flexible blueprint. Believe it or not, when you were just starting out, your skeleton wasn't really made of bone at all. It was mostly a soft, flexible model made out of cartilage. And the process of swapping out that cartilage for hard bone is called endochondral ossification. You can just think of it as a really, really long-term renovation project that lasts for your entire childhood.
And for any construction project, you need a crew, right? Well, your bones have two main teams. First, you've got the osteoblasts. These are your builders. They're the ones laying down the new material, the new bone. Then you've got the osteoclasts. Think of them as the demolition and remodeling crew. They clear out old, damaged bone to make way for the new stuff. This constant dance between building and remodeling is what lets our bones grow, heal, and get stronger.
And here's how that plays out in a long bone, like the one in your thigh, for instance. You start with that cartilage blueprint. Then the builders, the osteoblasts, start working right in the middle, in the shaft. But the bone keeps getting longer because of these special areas of cartilage at the ends called growth plates. And then, when you're finally done growing, those plates turn to bone too. They leave behind a little line, kind of like a scar, that shows where the construction zone used to be. How cool is that?
Okay, so that's the how. Now let's take a quick tour of the what, the finished product. Turns out we can split the whole thing into two major parts. And the grand total is 206. 206 separate bones make up the typical adult skeleton. And here's the thing, there are no extras. Every single one has a job to do in this amazing, intricate machine. So those 206 bones aren't just a random pile. They're organized into two main systems. First, you've got the axial skeleton. Think of this as the central pillar, the core of your body, your skull, your spine, your ribs. Its main job is stability and protection. Then you have the appendicular skeleton. This is all your appendages, basically, your arms and legs, plus the girdles that attach them. This is the part that's all about getting you from A to B.
All right, but hold on a second. We just talked about this rigid, strong structure. But we can move, right? We can bend and twist. That seems like a contradiction. So how does our body solve this incredible engineering problem? The answer is joints. No, seriously, just pause and think about that. You've got 206 hard, solid pieces inside you, and yet you can dance, or swim, or just type on a keyboard. How is all that freedom of movement even possible with such a rigid frame? It all comes down to joints, and we can basically group them into three categories based on how much they move. You've got synarthrosis joints, these are immovable. Think of the seams in your skull. Then you have amphiarthrosis, which allow for just a little bit of give. But the ones we're all familiar with are the diarthrosis joints. These are the freely movable superstars like your shoulder, your knee, and your elbow. And if you look at how these movable joints are built, it's just mind-blowing engineering.
The ends of the bones have this super smooth, rubbery cap made of cartilage. The whole thing is then sealed inside a tough sleeve or capsule that produces its own lubricating fluid. It's basically a perfectly engineered, self-lubricating hinge. It's incredible. And it's not a one-size-fits-all situation either. You've got all these different types, each designed for a specific kind of movement. You've got simple hinges in your elbow. You've got ball and socket joints in your hip that give you that huge range of motion. You even have this really unique saddle joint in your thumb. That's the one that lets us have opposable thumbs and grab stuff. In every case, the shape of the joint perfectly matches the job it needs to do.
So here's maybe the most important thing to remember from all of this. Your skeleton is never done. It's not a finished product. It has a life story, and you are writing that story every single day.
If we look at the timeline of our skeleton, it's pretty clear. You hit peak bone mass, your strongest, densest bones, right around age 25. Then for the next couple of decades, you're in a maintenance phase. That constant remodeling keeps things in balance. But as we get older, past 50, that balance can start to shift a little, and we might see a slow decline in bone density.
And our skeletons really do tell stories about who we are. One of the most obvious examples of this is the pelvis. A typical female pelvis is built differently from a male's. It's broader, wider, and more basin-shaped. And why? It's a perfect structural adaptation for childbirth. It's a beautiful example of how the body's design is driven by its purpose.
And that brings us to this powerful idea. Think about it. Every time you work out, every time your muscles contract and pull on a bone, it sends a signal to those builder cells, the osteoblasts, and tells them, hey, we need to be stronger right here. This isn't just a nice idea, it's a physiological fact. Your lifestyle, literally, physically, shapes the architecture of your skeleton.
So, if there's one thing you take away from this, let it be this. Your skeleton is not just some passive frame. It is listening. It is actively responding to every single thing you do. The stress you put on it, the exercise you give it, the way you move, it's all being logged, recorded, and built into the very fabric of your bones. So the real question is, what story are you telling your bones to write?